this tutorial, we're going to learn how to solve equations and inequalities with absolute values. So let's take a look at the first couple examples. So here, in example 1, we have the absolute value of 2x minus 1 equals 3. Now, if you remember with absolute values, it's the distance that a certain point is from the origin. So whether it's a point on the negative side or the positive side, the distance will still be the same. So for example, here, this absolute value has a distance of 3. So either that could be 3 in the positive direction or 3 in the negative direction. So when we solve this, we need to consider both cases. So either this 2x minus 1 could equal 3, or this 2x minus 1 could equal a negative 3 on the number line. So let's solve this left one first. So we'll add 1 to get rid of that on that side. And we'll do the same thing to the other side. That leaves us with 2x equals 4. Now here, to get x by itself, we just need to divide the 2 out of there. And then do the same thing to the other side. So here we get x equals 2. So there's one solution. Now let's take a look at the second one. So we have 2x minus 1. If we want to solve for x, we need to get rid of everything else. So let's add 1. And then we'll do the same thing to the other side. That leaves us with 2x equals a negative 2. Because negative 3 plus 1 is a negative 2. Now we just need to divide the 2 on this side to get rid of it. Now we're left with x equals a negative 1. Because negative divided by positive is a negative number. So there's our two solutions. Now we could always double check these to make sure that they're correct. So let's do that. So here, when x is 2, let's plug that into our original equation here. So we have 2 times x, which is 2, minus 1, and that should equal 3. So 2 times 2 is 4, and 4 minus 1 is 3. Well, the absolute value of 3 is 3. So that's good. And we do the same thing for our second x value. If we plug in the negative 1, we have 2 times negative 1 minus 1. And that should equal 3. So 2 times a negative 1 is a negative 2, and the negative 2 minus 1 is a negative 3. Well, the absolute value of a negative 3 is 3. So that checks as well. So we know both of those solutions are good. Alright, now let's look at example 2. So here we need to do a few steps first before we can solve it. So we want to get the absolute value expression by itself first. So in order to do that, we need to first get rid of this negative 7. So since it's negative, we want to add 7 to cancel it out, and then add 7 to the other side. And we're left with 2 times the absolute value of x plus 3 equals 12. So now we need to get rid of this 2. So since it's being multiplied to the expression, we'll divide it to cancel it out. And then divide on the other side as well. And that leaves us with the absolute value of x plus 3 equals 6. Now we're in a similar position as we started in example 1. So the absolute value is the distance that a certain point is from the origin. So right now we know that distance is 6. So either it was on the positive side so being positive 6, or it's on the negative side of the number line, being negative 6. So we need to look at both those cases. So x plus 3 could be a positive 6, or x plus 3 could be a negative 6. So now let's solve for x on this first one here. So we just need to subtract 3 from both sides, and that leaves us with x equals 3. Now let's do the other one. Again, subtract 3 from both sides, and that leaves us with x equals a negative 9. It's negative 6 minus 3, it's negative 9. So those would be our two solutions for this equation. And again, we could plug these two values in to make sure that it checks. We're going to skip that part and move on to a new example. So here, for the example 3, it's a little bit different. We actually have an x over here on the other side as well. Now, the principle still hasn't changed. This is still referring to a distance. So either this 2x plus 1 could be on the positive side of the number line, or it could be on the negative side. So we'll need to look at both cases. So x minus 7 could equal 2x plus 1, or in other words, a positive 2x plus 1, or it can equal a negative 2x plus 1. So now again, let's solve for x, starting with this one. So here, we want to get the x's on one side, so let's move this x over here with the 2x. So we'll subtract x, do the same thing to the other side. So here we're left with negative 7 equals a 2x minus x is just 1x, and then plus 1. Now to get x by itself, we just need to get rid of this 1 here, move to the other side, and that leaves us with a negative 8 equals x. So there's one solution. Now let's take a look at this one and find our other solution. So first, it might be easiest to simplify this expression here. So we'll distribute the negative 1, it's an invisible 1 there, to both the 2x and the positive 1. So negative 1 times 2x will give us a negative 2x, and then a negative 1 times a positive 1 will give us a negative 1. So now again, let's try to get the x's on one side. So let's move this 2x over. So we'll add it to this side, and then do the same thing to the other side. So 1x plus 2x will give us 3x, and then bring the negative 7 down. And we're left with negative 1 on the right side here. So now to solve for x, we want to get rid of this negative 7 first. So we'll add 7, and then do the same thing over here. And that leaves us with 3x equals positive 6. So now to solve for x, we just need to divide the 3, and then do the same thing on the other side. And that gives us x equals 2. Now, when we have x's being involved on both sides, we need to be careful. Sometimes it could produce a solution that actually doesn't work. So we need to check both of these. Let's first plug in the negative 8 for x and see if it works out correctly. So if we have the absolute value of x minus 7, where x is negative 8, and then minus 7, so that's where our x was. And that should equal 2 times x, which was negative 8, plus 1. So a negative 8 minus 7 gives us a negative 15. and that equals 2 times a negative 8. So positive times a negative is a negative 16 plus 1. That gives us the absolute value of 15, or of negative 15, equals negative 15. Well, if you remember, if you take the absolute value of a number, you'll always get a positive result. Well, here it's giving us a negative 15. So that can't be right. So this solution here of x equals negative 8 is what they call an extraneous solution. So that solution actually does not work for this equation. But let's double check our other solution, x equals 2. So we'll plug that in for x, get 2 minus 7 in the absolute value equals a 2 times x, where x is 2, plus 1. So here in the absolute value we have 2 minus 7, which gives us a negative 5 in the absolute value, equals a 2 times 2, which is 4, plus 1, which gives us a positive 5. Now when you take the absolute value of negative 5, you do get positive 5. So that's good. So x equals 2 checks out.